This is review 5, or unit 5, review number 2. This is question number 7 and 8. So number 7 here, it says, an 8-inch by 12-inch sheet of cardboard is folded to make an open box. So this is that box problem that we've always done. I have a rectangle, we have 12 inches by 8 inches. All right, determine the dimensions that will maximize the volume. So this is the one problem that we do not need a helper equation. We're going to maximize my volume here. All right, what I'm going to do is I'm going to cut out the squares on each one of the corners. Remember, they're going to be equal, otherwise the box wouldn't work out. All right, so we need to know what those dimensions are that we're going to be cutting out. Well, we don't know what that is right now, so we're going to just call that x. So we have those x's going all the way around. That's eventually going to be my height, because this pink rectangle here is going to be my base. So my volume is always going to be the area of the base times by the height. Well, the height I now know is x. This is going to be the back side, this is the right side, the front side, and the left side of my box. I'm going to fold those up. All right, so this pink part, again, is my base. How do I know what those dimensions are? Well, what I do know is that this whole bottom side here is 12, and this pink side is shorter than that, so that's going to be 12 minus something. What am I subtracting? Well, an x on this side and an x on that side for 2x. Likewise, here, this pink side is shorter than that 8. It's short again by those 2 x's right there. So that's going to be 8 minus 2x. So volume here, length times width, or the area of the bottom, 12 minus 2x, times by the 8 minus 2x, and then ultimately times by your x. And from here, it's just now a matter of foiling this. So volume here is going to equal to 96 minus 40. Yep, 40x, 12 times 2 is your 24, minus the 16 is the minus 40x, and then a positive 4x squared. So the x on the outside, distribute that in. Volume here is equal to 96x minus 40x squared plus 4x to the third. Take your derivative. Volume here is going to equal to 96, or I'm sorry, d prime rather, is going to equal to 96 minus 80x plus 12x squared, and you set that equal to 0. From here, we're going to try to factor out as much as we can. We can factor out a 4, and I'm going to rewrite this in descending order. So that's going to give me a 3x left over for that first term, so 3x squared, minus 20x, excuse me, minus 24. And again, that's still set equal to 0. You can factor this any way you want. You can try to factor that, I should say, any way you want. Go through and try to solve it. This actually does not factor. Okay, so if it's not going to factor, how do I go through and solve it? Well, 4 can pretty much go away. Take the 3x squared minus 20x minus 24. Plug that into y1 on the calculator. Take 0, plug it into y2. We've done this over and over again. And you get 2 answers here. You get x is equal to 1.569 and 5.097. So it intersects twice. You need to find out both of those intersections. Now, one of those is going to work. Typically, it is the smaller of the two. All right. Here, if I took the 5.097 and plugged it in, when I plugged it into the 8 minus 2x, that's going to give me a negative number. So that cannot be my answer. So I take the 1.569, plug it into the 12 minus 2x. Again, I'm just plugging it really into these 3 different dimensions up here. It's 12 minus the 2 times by 1.569, 8 minus the 2 times by 1.569, and then itself. And when you do so, you end up with 8.862 inches by 4.862 inches by then itself, which is the 1.569 inches of the dimensions of that rectangle. Number 8. So number 8, rectangular prism storage area is made of wood on the sides and bottom and steel on the top. So let's think about that. So wood on the sides and the bottom. So the 4 different sides and the bottom are made out of wood, and then it's made out of steel on top. We did a problem very similar, but it was concrete on the bottom and the sides. The base is a rectangle. So typically we've done a square where it was x, x, and this is y. Here it's a rectangle, so it's different. So the base is a rectangle where one side is 4 times as long. So here's one side is x. The other side is 4 times that one. All right, the wood is sold for $4 per square foot, and the steel is sold at $10 per square foot. Okay, so that's my area. So the volume must be 384 cubic feet. So volume, it's giving me the volume. Since it's giving me the volume, that must be my helper equation. So the volume here has to be 384 cubic feet, since it is volume. Well, what is my volume? Volume, you take your 3 dimensions and multiply them together, so that's going to be 4x squared y. So 384 is equal to 4x squared y. And I'm going to solve that for one of those. Typically we solve for y, and that's exactly what we're going to do here. So I'm actually going to go ahead and do that right now. I'm going to divide by my 4x squared. That's going to give me my 96x squared is equal to my, 96 over x squared is equal to my y. Do that correctly. Remember, you're dividing, so it's going to be on the bottom there. 384 divided by 4 is 96. So there's my helper equation. So now I need to decide, well, where am I plugging that in? Since this is a prism, we've always done volume and a surface area. All right, it tells you the money there is based off of surface area. And since it gives me money, we know we're going to have to convert that surface area into a cost function. So, first of all, my surface area. When I go through and do it, I have my top, I have my bottom, I have my left and right, and then I have my front and back. So I have my top plus, I'm going to say my front and back, plus my left and right, and then plus my bottom. Now I'm doing this all differently because the front, back, and left and right here are not the same. Typically, they all four are when it's a square on the bottom, but it's not. The top is made out of a different material than the bottom is, so they have to be separate as well. All right, so surface area. When I go through and do this, I'm going to have surface area here is going to be equal to, what's the area of the top? Well, it's going to be 4x times x, that's 4x squared. All right, plus, what's the area of the front and the back? So the front face is this one right here. That's going to be 4x times by y. And then remember, there's a back side, so it's 4x times by y, but there's two of them, so it's really 8x y. Plus now the left and the right, so that's x times by y. Here's the right side, and there's two of those, so that's plus 2xy. And the bottom is also going to be a 4x squared. Now, before we go through and adding like terms, we have to incorporate the cost into that. We have to convert this to be a cost function. So if I want this to be cost for my surface area, I need to know what the cost is. And it told us that the top here was made of steel, and that was $10 per square foot, since the steel is on the top. So this top is going to be $10. And the rest of it was made out of the wood, and that was $4 per square foot. So it's $4 for this piece, $4 for that piece, and $4 for this piece. So we have to multiply that in. So whatever the square footage is, you multiply by the total cost. So this is going to be 40x squared plus 32xy plus 8xy plus 16x squared. And once you've incorporated the cost in there, now you can just do this like a regular math problem. Now you can go through and solve this like I'm going to be adding like terms. That's exactly what I'm going to do. So my cost function here is going to equal to 40x squared plus 16x squared is 56x squared. Plus 32 plus 8 is going to give me a 40xy. So that's as simplified as I can go. But now I need to replace. And again, we're going to replace this y with this 96 over x squared. So my cost is going to equal to 56x squared. Plus I have 40x times by that 96 over x squared. All right, so when I do this now, I have my cost is equal to 56x squared. I'm going to do my 40 times by 96. Let's see if I have that in front of me. I do. It is 3,840. So that's plus 3,840. And I have x over x squared, which means there's an extra x in the bottom. So it's over x, but I'm going to write it as x to the negative 1. So I can now take my derivative. So now I take the derivative. This is going to be the cost function prime. That's my derivative. Is equal to 112x minus 3,840 x to the negative 2. And again, I'm going to set that equal to 0 as we've always done. Now it's a matter of solving this. So I have 112x is equal to 3,840 all over x squared. Again, in that step, I added the 3840, the x to the negative 2 to the bottom. Next step, multiply by x squared. 112x to the third is equal to 3,840. Divide by your 112. I don't have that number in front of me. And then take your third root. When you do that, those two steps divided by 112 and the third root, give x is equal to 3.249. So that is the x value there. Now remember, it says determine the dimensions. So I want the dimensions. There's three dimensions, x, 4x, and y. So I have the x. I now need the 4x, and I need the y. So when I do this, this is going to be 3.249, and this was inches if I remember correctly. No, it's feet, so it's feet by, now the 4x, so I just take this number and I multiply it by 4, and that's going to give me, 12.996 feet by, and now my height, my y. I'm going to take my 3.249, my x, I'm going to plug it into my helper equation, and I get that that is 9.094 feet. That is the final answer for number 8.